So you're supposed to find or determine if these are inverses of each other. Now, to do that, we're going to have to do what's called function composition. So to give you an idea of what that is, if I have f of x equals 2x plus 7 and g of x equals 3x minus 5, it looks like this, f little g sub x, or you'll also see it written like this. What that means we're going to do is we're going to take the second one, so see how this g is inside of f? We plug this stuff into that x right there. Okay, so it's going to look like this, 2 parentheses, the g equation, okay, and then we distribute, so I'd have 6x minus 10 plus 7. So I'd have 6x minus 3 would be the function composition f of g. And then we would also do g of f, meaning we're going to take this f function and plug it into g. Okay, so that also looks like this. So this is called function composition, and you're like, we're supposed to be doing inverse functions. We use function composition to determine if they are inverse functions. Okay, so if I were to do this, I'll finish out this problem, g of f of x. So there's my g as 3, then x is 2x plus 7. So I replace the x with 2x plus 7. Okay, so see how this x was right here? I replaced the x with the f function. So now I'd get 6x plus 21 minus 5, which is 6x plus 16. Now, when we do this, if f of g of x and g of f of x both equal x. So if they both, so if f of x and g of x equals x, both of them, then f and g are inverse functions. Okay, so what inverse means is it undoes what the other does. For example, if I have x plus 7, what undoes plus 7? Minus 7. So they undo what the other has done. Much like when we have 3x equals 15, to undo the multiply by 3, we divide by 3, and x equals 5. Okay, the undoing to get x alone is what the inverse is. So if I had like f of x equals 3x, the inverse would be to divide. Okay, so this would be 1, and this would be its inverse. That's the fancy way to write inverse, f negative 1 of x. Okay, so that's the fancy way to write inverse. Most of you are familiar with looking at these as a table. And if I have like, this is f of x, and it's like, so for example, if I have this 1, 2, 3, 4, 5, and then y is 2, 4, 6, 8, 10, the inverse of f looks like this. 2, 4, 6, 8, 10, 1, 2, 3, 4, 5. So it takes the y answer, plugs it in, and gives us back what originally was the x answer. So that's what an inverse does. It undoes and takes us back to what we started with. Okay, so we want to know, are these inverses of each other? So to determine if they are inverses of each other, we're going to do f of g of x. And I'm just going to write them different so you can see how they're both written. And g of f of x. So realize that f of g of x is this one. A lot of people think of this as fog and goff. So that's just function composition. It's like foggy and you're working with, I don't know, function composition. So anyways, f of g of x. That means we're going to plug g into that x. So I take that. So this equals x plus 3. So I've replaced this x with the bottom one. And then we have the minus 3. So those go away and I'm left with x. G of f means I'm going to take this stuff whoops, I'm going to take this stuff and plug it in for that x. So that is x minus 3, because I replaced this x with the top one, plus 3. These 3's go away, and I'm left with x. So do g of f and f of g, Fogg and Goff, each equal x? Yes. So therefore they are inverses. Okay? So yes, they are inverses. So now we're going to do the same thing on this. F of g of x and g of f of x. Okay? So f of g, that means I take g and I plug it into that x right there. So I'm going to have 3 parentheses x divided by 3. Well, those 3's cancel off and leave me with x. Now g of f means we're going to take the f equation and put it in for the x in g. So where the x was on top, I replace that now with 3x. Well, 3 divided by 3 go away and leave me with x. So since they both equal x, these are inverses. Okay, so now let's do the next one. F of g of x. So I'm going to take the g equation and plug it into x on that f equation. So that's 3 plus 2. So I replace that x with x over 3 minus 2. So now, realize that this 3 on the outside of the parentheses really means I have to distribute it to both of those. So what I really have is 3x over 3 minus 6 plus 2. Well, those go away and I get x minus 4. Well, that's not equal to x. Okay? If it's not equal to x, there's no way they can be inverses. So I don't even need to do the second one. I can just say no, they are not inverses. So notice on these ones up here, I didn't have to distribute the 3 really because there wasn't a minus or a plus or anything. I could just take it 3 and divide it here. But here there's a minus, so I have to distribute this 3 on the outside to both of those. Okay, so make sure you do understand that difference and just don't go, oh yeah, those cancel off and those cancel off and we're left with x. Okay, don't do that. Make sure you distribute that 3 and then you see that no, they are not inverses of each other. Okay. Okay, so now question number 4 and 5. So again, f of g of x. So I'm going to take this g equation, plug it into x on the f equation. So I have 2, that's where the x was, minus 5 over 3. So I'm going to replace where the x was with 3x plus 5 over 2. Okay? So this whole thing is being divided by 2. And so since the whole thing's being divided by 2, these 2 will cancel off. Okay? If you wanted to, you could do it this way, distribute the 2. So that's 6x plus 10, and those are each divided by 2. And that gives you 3x plus 5. So now I've done this first part. I've done 3x plus 5 minus 5 all over 3. These 5's go away, and I'm left with 3x over 3. So those go away, and I'm left with x. So that's f of g. Now let's do g of f of x. Okay, so that means I'm going to take this stuff and plug it all into that little itty-bitty x right there. So that is 3 parentheses, all that stuff, plus 5 over 2. So see, this is my g equation, but it says I'm going to take my g equation and replace the x with all of this stuff. Remember how I said this is the input? That's the value we're plugging in, so we're going to plug that in for all of these x's. So 2x minus 5 over 3. So again, much like the last one, these 3's will cancel off, and I have 2x minus 5 plus 5 all over 2. I can combine like terms on the top, so minus 5 plus 5, those go away, and I'm left with 2x over 2. The 2's cancel off, and I'm left with x. So since they both equal x, yes, they are inverses. Okay? Now on the bottom one. So f of g of x. So I'm going to plug this all into there. So I have 2 where the x was. So everything's the same except for I'm replacing where the x was with the g equation. So that is the square root of 3x plus 5 squared. A squared and square root, they cancel each other off. Okay, so these cancel each other off. So the squared and square root, they take each other out. So now I have 3x plus 5 over 2 minus 5 all over 3. Those 2's will now cancel each other off. So now what I have is 3x plus 5 minus 5 all over 3. Okay, so these 5's go away and I'm left with 3x over 3. The 3's cancel, I'm left with x. So that was f of g. But now we've got to do g of f. So now I'm going to take the square root of 3, leave a parentheses, plus 5 over 2. So this is my g equation, but now we're going to replace the x in the g equation with the f equation. So that's 2x squared minus 5 over 3. Again, these 3's will cancel off. So I now have the square root of 2x squared minus 5 plus 5 all over 2. The minus 5 and plus 5, those go away. So now we have 2x squared over 2 all inside the square root. So the 2's cancel off. I'm left with the square root of x squared. The squared and square root cancel each other off, and I'm left with x. So yes, these are inverses. Okay. So now, let's move on to question number 6, 7, 8, 9, and 10. So these problems, you're supposed to find the inverse. So now that we've determined how to see if functions are inverses of each other, now we're just going to say, let's just find what the inverse is. So here's the general idea. We have f of x equals something, right? The first thing we're going to do is we're going to change this to a y. Okay? Now the next step, and you can realistically do this all at once, you're going to swap the x's to y's and the y's to x's. And then the third thing, you're going to solve for y. So here we go on the first problem. This is really a y. Swap the x and y. So now I have x equals y squared minus 5 over 3. So now it says solve for y. So to solve for y, I get rid of a divide by 3 by multiplying by 3. So those are gone. So I have 3x equals y squared minus 5. My next step in solving for y would be plus 5 to each side. Because this doesn't have a variable, I cannot combine it. So it's now 3x plus 5 equals y squared. And so now to get rid of the square root, the squared, we square root it. So y equals the square root of 3x plus 5. The final step would be change y back to f of negative 1. So that means that's the inverse of f. That's what that little negative 1 means. So the inverse of f is the square root of 3x plus 5. If I were to plug this in for that x over my f, it would cancel everything off and leave me with x, and vice versa. If I were to take this x squared minus 5 divided by 3 and plug it into here, everything would cancel off and just leave me with x. So on number 7, this is really the y. We're going to swap those places. So x equals 5y cubed plus 7. So now we're going to solve for y. So I'm going to minus the 7 from each side. So x minus 7 equals 5y cubed. So now to get the y cubed alone, we divide by 5. And I divide the whole thing, not just the x, not just the 7, but the whole thing. So now I have y cubed equals x minus 7 over 5. So now I cube root it. So y equals the cube root of x minus 7 over 5, where the inverse of f is the cube root of x minus 7 over 5. Okay. Question number 8. Again, we're going to change f of x to y. Now we're going to swap those. So I'm going to have x equals 3y squared over 7. So to get rid of a divide by 7, you times by 7. So the 7's are gone. So now I have 7x equals 3y squared. My next step will be to get the y squared alone. So to do that, I divide everything by 3. Now y squared equals 7x over 3. And to get rid of the y squared, we take the square root of the whole thing, not the top, not the bottom, but of the whole thing. So y equals the square root of 7x over 3. And my last step is to change y back to f negative 1 of x equals the square root of 7x over 3. So that's the inverse of that. Okay, so that's the first 3 questions. Now we have the last 2. And then we're done with this assignment. Okay, so come on. Okay, question 9 and 10. Let's do 9 first. That's y. Swap the x and y, so x equals 9y squared minus 7. Now solve for y, so we're going to get rid of the minus 7. We add 7 to each side. So x plus 7 equals 9y squared. Divide it by 9. So y squared equals x plus 7 divided by 9, because these 9's canceled off. And now to get rid of the squared, we take the square root of each side. So I square root this and square root this. Y equals the square root of x plus 7 over 9. So that's our inverse. Just thinking about this, I had this thought that how do we know that we aren't using the plus and minus? If I were to graph this, it would look something like this. And this would be a function. Okay, it passes the vertical line test. But in order to have an inverse, you cannot have a horizontal line that goes through it twice, like this. And so realistically, this would not have an inverse. So in a way, I kind of messed up. So what they do to fix that is they say, let's restrict our graph for our domain to only be half of it. So they say we're only going to use x's that are greater than or equal to 0 on this problem. We're only going to use half of it. And then when we do the inverse, it's going to look something similar to this. Okay? And that's only going to be the positive case. Or they say, let's only use the left side of this graph. And if that were the case, so I have a graph that looks like this. If we only use the left side, then my inverse would actually be the negative square root of this. Okay? So I didn't write this on there. I'm kind of showing you how to do this, and I jumped ahead of where I should be. But realize if it's something squared, most likely there's going to be a restriction on the domain. So this would say x is greater than or equal to 6. And then we only use one of the square roots. We don't use both of them. We only use the positive case. Unless we said x is less than negative 6, and then we would use the negative case when we take the square root. So realize that's how that works. All of these that are squared really should have restrictions on the domain, because otherwise, if I were to graph them like this, you'd see that the horizontal line goes through twice. And if a horizontal line goes through it twice, there is not an inverse. Okay, we can't find an inverse if the horizontal line goes through it twice. So to fix that, we put a restriction on the domain so that we're only looking at half of the graph when it's squared. And then the horizontal line only goes through it once because this other half is wiped out. And so that's an important idea. Sorry, I skipped it at the beginning, but hopefully you kind of get that idea that in order to have an inverse, a horizontal line, you'll have some funky looking graphs that look kind of like this. So these are some functions that you could run into. And when you get to those, if you draw a horizontal line anywhere, oh man, that goes through all kinds of different places. Even if you draw it up here, oh, it goes through twice up here. So as soon as it crosses in more than one place, you'd say this doesn't have an inverse, not invertible. Not sure that's how that's spelled, but something like that might be able, but not invertible. So you can't take an inverse of it, is all that that means. So anyways, just to clarify that. So now moving on to this last one, let's find the inverse. It should have this x is greater than or equal to 6. So now what we're going to go ahead and do is change this to y. Now swap the x and y's. X equals 2, y minus 6 squared plus 7 all over 3. To solve this, we're going to get rid of this divide by 3. So I multiply by 3 to each side, and those cancel out. What I do to one side, I do to the other. So now I have 3x equals 2 parentheses y minus 6 squared plus 7. And now we want to get this stuff that's squared all by itself, so I'm going to get rid of this 7. So I minus the 7 from each side. So 3x minus 7 equals 2 parentheses y minus 6 squared. Now we're going to get rid of the 2 out here, so I divide everything by 2, running out of room. 3x minus 7 over 2 equals y minus 6 quantity squared. And now we need to get rid of the squared, so I take the square root. So now what we have is y minus 6 equals the square root of 3x minus 7 all over 2. And to finish up, we need to get y alone. So I add 6 to each side. And that's my inverse, because y is all alone, so I replace the y with f negative 1 of x. And that's my inverse. The square root of 3x minus 7 all over 2 plus 6. Okay. So hopefully that helps you to find the inverse and determine if functions are inverses of each other. Realize that normally we would start by saying, is it indeed invertible? Does it have an inverse? Okay. And we'd graph them and say, no, this does not pass the horizontal line test. We can't find it. But then we fix that problem by putting restrictions on the domain. Let's only use half the graph. And then we can see that, yes, it does have an inverse, and we can find it. So anyways, that's how that works. And that finishes up the last section in this unit. So